Section 7.7 is solving radical equations. Step 1 says to isolate the radical on one side of the equation. So in example 1a, we've got to move the 4 on the other side. And we get the square root of x plus 2 is equal to 3. Now, step 2 says raise each side of the equation to a power equal to the index of the radical. That's a square root, so we are going to square both sides. And when you square a square root, what's inside just falls out. Then we're going to subtract 2 on both sides, and we get x is equal to 7. Now you must check, because sometimes they don't work. So we're going to plug it in and check. It does check. Okay, example 1b. We are going to square both sides. We already have the very first radical isolated, so we're going to square both sides. When we square the left side, it just falls out. But when we have this binomial 2 minus square root of x squared, remember, if you had a minus b quantity squared, remember you square the first term, multiply the two terms together, and then double it and get negative 2ab, and then square the last term. So that's what we're going to do over here. We are going to square the first term and we get a 4. Multiply the two terms together, that's a negative 2 squared root of x. Double it, and we get a negative 4 squared root of x. And square the last term. The square root of x times the square root of x is a positive x. Then we're going to subtract x on both sides. Subtract the 4 on both sides. So we get negative 16 is equal to negative 4 square root of x. Then we have to get the square root of x by itself, so we're going to divide by negative 4. And we get 4 is equal to the square root of x. Then we have to get rid of that radical, so we're going to square both sides. And we get 16 is equal to x. Now let's check it. And when we check, we get 2 is equal to negative 2. Okay, that means no solution because it does not check. Okay, example C, we're going to add 1 to both sides. Then we're going to square both sides. Now we have to check it. And it checks. So we're good to go. Example D, we're going to square both sides. Get rid of the square root. When we square a square root, what's inside just falls out. Now on the right side, we're going to have to use that shortcut where we square the first term and get 25. Multiply the two terms together, and we get 5 square root of x. Double it, gives us 10 square root of x. Square the last term, and we get x. Now we're going to subtract x on both sides. Then we subtract 25 on both sides. Get negative 10 is equal to 10 square root of x. Then we're going to divide by 10, and we get negative 1 is equal to the square root of x. Now we're going to square both sides again, and we get positive 1. Now to check, plug it in. And notice you get 4 equals 6. What that means is that if we graphed these two equations and put in the graphing calculator, they do not intersect at a point. Therefore, there is no real solution. The abbreviation for no real solution is a 0 and a slash through it. So you have to check every single problem to make sure it checks or not. example 2a, we have a binomial to the 1/3 power. So our goal is to get that by itself. We've got to get 6x minus 3 to the 1/3 power by itself. So we are going to add 4 and then divide by 2. So we get 6x minus 3 to the 1/3 power. Now, we've got to raise that 1/3 to some power that is going to give us 1. So 1 over 3 times 3 over 1 gives us 3 over 3, which is 1. So we're going to multiply we're going to do everything to the 3rd power. And we have to do the left side and the right side to the 3rd power. And 2 to the 3rd power is 8. Solve for x. Check it. Now you might want to plug this into your graphing calculator to check. Might be a little bit easier. Or we can cross reduce, and we get 11 minus 3, which is 8. Now right there at 8 to the 1/3 power, that is saying the cube root of 8. And the cube root of 8 is 2, so 2 times 2, and we check. Okay, now let me back up for just a minute. Right here, if the power was a 1/4, then we would do everything to the 4th power. If the power was 1/5, then we would do everything to the 5th power. Okay, our goal is to get the exponential by itself, so we have to subtract 1 on both sides. Then we have to cube everything. And then we solve for n. And we get -1. Now we have to check it. And it checks, so we're good. Next example, we have to add 2 to both sides. Then, again, we want the exponential form by itself, so we have to get rid of that 3, so we're going to have to divide by 3. Now we have to cube everything because it's to the 1/3 power, so to get rid of it, we have to cube everything. When you cube a fraction, you get 2 to the 3rd power is 8, and 3 to the 3rd power is 27. Subtract 1 on both sides. Solve. Now another way we could have done that right here, we could have cleared our fractions by multiplying each term by the least common denominator. So put that over 1, put that over 1, and multiply each term by 27. That might be easier. And 27 times 5y is 135y. Minus 27 is equal to 8. And solve, and you will get 7 over 27. And then you would need to check. My checking is going to be right on top of that. Let me erase this. Once again, you might want to put this in your graphing calculator to check. And your goal, when you put it in your calculator, you want it to equal 0. Example 3a. We want to get the radical by itself, so we have to add 6, and then we have to divide by 3. Now we have to do everything to the fourth power, and then solve for n. Check it. And it checks. Every single problem you have to check. Okay, here's a couple problems. I'm going to do 25 for you. You have to square both sides. When you square a square root, what's inside just falls out. Now, when you square the first term, you get 25. Then you multiply the two terms together. 5 times the negative square root of x plus 1 is a negative 5 square root of x plus 1. But we double it and get negative 10. And then we're going to square the last term. When you square a square root, what's inside just falls out. And when you square a negative, you get a positive. So that's x plus 1. Combine like terms. Subtract x on both sides. Then we're going to subtract 26. Divide by negative 10. Then we're going to square both sides again and then solve for x. Check it. Here's 43. Okay, that is the end of section 7.7.